Have you ever looked up at the night sky and felt a profound sense that what you are seeing is not the full story? A feeling that just beneath the surface of reality, beneath the predictable dance of planets and the silent glitter of distant stars, there lies a code, a structure, a hint that our universe might be something other than what it seems. Tonight, as you settle in and allow your mind to drift, we will explore one such hint, a cosmic anomaly so strange, so statistically improbable, that it has been nicknamed the axis of evil. It is a feature embedded in the very first light of the universe, a faint whisper from the dawn of time that might just be the most compelling evidence we have that our world is not a product of random chance, but a carefully constructed artifice, a simulation, prepared journey to the edge of cosmology and philosophy, to question the very fabric of existence as we uncover the story of the glitch in our matrix. To understand our story, we must first travel back in time, not just hundreds or thousands of years, but billions. Let your mind drift back through all of human history, past the age of dinosaurs, beyond the formation of our Earth itself. We are going back to the very beginning, to a moment just after the Big Bang. The universe was an impossibly hot, dense soup of particles and energy, a blinding fog where no light could travel freely. For 380,000 years, this was the state of existence. But as the universe expanded, it cooled. And in that cooling, something miraculous happened. Protons and electrons found each other, combining to form the first atoms. In that moment, the universe, for the very first time, became transparent. The light that had been trapped within the cosmic fog was finally set free, released in a brilliant flash that filled all of space. This light, this first light, is still traveling today. It has been stretched by the expansion of space, cool from a brilliant, white-hot glow to a faint, invisible microwave hum. This is the cosmic microwave background, the CMB. It is the oldest light in the universe, a fossil, a baby picture of creation itself. And it carries within its gentle warmth the secrets of everything that was and everything that would ever be. Let us begin by visualizing this ancient light. Imagine you are floating in the deepest, most absolute darkness of space. There is no up, no down, no sound, just a profound and peaceful stillness. Now picture that this darkness is not entirely cold. From every single direction, an impossibly faint warmth touches you. It is a uniform, gentle glow, just under 3 degrees above absolute zero. This is the cosmic microwave background radiation. It is not coming from a single star or galaxy. It is coming from everywhere at once. It is the very fabric of space-time itself, still humming with the residual energy of its own birth. For decades, astronomers believed this glow was perfectly smooth, perfectly uniform, a testament to a universe that, on the grandest scale, was homogeneous and balanced. This theoretical perfection was known as the cosmological principle, the idea that no matter where you are in the universe, and no matter which direction you look, the cosmos should appear roughly the same. It was a comforting, elegant idea, a universe without a center, without a special direction, a cosmic democracy where every point in space was equal. This faint, ancient light was the ultimate proof of this principle. It was a blank canvas, a a perfect sphere of faint light upon which the entire future of the universe would be painted. And for a long time, our instruments confirmed this beautiful, simple picture. The universe was, in its infancy, almost flawlessly uniform. This idea of uniformity is deeply soothing. Picture a perfectly still lake at dawn, its surface an unbroken mirror reflecting a gray, featureless sky. That was our initial understanding of the early universe. Or think of a perfectly crafted crystal sphere, without a single flaw or internal fracture, where the light passes through equally from any angle. This was the universe described by the standard model of cosmology. It was a universe of profound balance and simplicity. The laws of physics, as we understood them, predicted this. Any large-scale variations, any preferred directions, would violate this fundamental principle of isotropy. It would be like finding that the perfectly still lake had a single permanent ripple extending from one shore to the other for no apparent reason. It would suggest an outside influence, a hidden structure, something that broke the perfect symmetry. Scientists built their entire understanding of cosmic evolution on this foundation of uniformity. It was the starting point for every calculation, the assumption behind every model of galaxy formation. The idea was that this near-perfect smoothness was not an accident. It was a fundamental property of space itself. And so, when we began to build instruments powerful enough to see this ancient light in greater detail, the expectation was to find only the tiniest, most random fluctuations, like microscopic dust motes on the surface of that crystal sphere. These tiny variations were necessary, of course. They were the seeds of everything we see today. These expected fluctuations are the key. While the universe was almost perfectly uniform, it couldn't be completely perfect. If it were, gravity would have had nothing to act upon. There would be no clumps, no clusters, no galaxies, no stars, no planets, and no us. So, cosmologists predicted that the baby picture of the universe should have tiny temperature variations, minuscule, hot, and cold spots. Imagine that crystal sphere again. But now, if you look incredibly closely, you see that its material is not perfectly uniform. It has microscopic variations in density, almost invisible, scattered completely at random. These denser spots, the cold spots in the cosmic microwave background, represent areas where there was slightly more matter. These are the places where gravity would begin its slow, patient work over billions of years, pulling matter together to form the vast cosmic web we see today. The less dense areas, the hot spots, would become the great cosmic voids. The crucial point was that the size and distribution of these spots were expected to be completely random. There should be no pattern, no preferred size, and certainly no preferred direction or alignment. It should look like a random spattering of paint on a canvas, a cosmic static that held the blueprint of our future, but a blueprint written without any overarching design or direction. It was the beautiful, elegant signature of a universe born from a quantum fluctuation, a product of pure, unbiased chance. To see these tiny imperfections, to truly capture the baby picture of our universe, humanity embarked on one of its greatest scientific journeys. In the year 2001, NASA launched a satellite called the Wilkinson Microwave Anisotropy Probe, or WMAP for short. Its mission was simple in concept, yet breathtakingly complex in execution: to create the most detailed full sky map of the cosmic microwave background ever made. Imagine a cartographer setting out to map an entire world, but a world made of the faintest light imaginable. WMAP was placed in a special orbit, 1,000,000 miles from Earth, where it could stare into the abyss, shielded from the noise of our own planet and the sun. For 9 years, it patiently scanned the heavens, measuring those minuscule temperature differences, variations of mere millionths of a degree. The data it collected was a stream of numbers, a flood of information that had to be carefully processed and cleaned. Scientists had to subtract the light from our own galaxy, the interference from distant quasars, all the noise of the modern universe, to isolate that one pure ancient signal. It was like trying to hear a single faint whisper in the middle of a roaring stadium. And slowly, painstakingly, a picture began to emerge, a map of the universe as it was 13.8 billion years ago. And it was more beautiful and more mysterious than anyone had ever imagined. The first map from WMAP was a triumph. It was an oval-shaped image of the entire sky, splashed with mottled patterns of red and blue, representing the hot and cold spots. It confirmed the standard model of cosmology with stunning precision. The average size of the spots was exactly what theory had predicted. The overall picture was one of triumphant success. It was a moment of deep satisfaction for the scientific community. The universe behaved as it should. But as scientists looked closer, as they began to perform more detailed statistical analyses on the map, a quiet, unsettling feeling began to grow. There was something in the data that shouldn't be there. It was subtle, almost hidden in plain sight. When they looked at the largest patterns on the map, the biggest waves of temperature fluctuation, they noticed a strange alignment. These large-scale features were not randomly distributed across the sky as they should have been. Instead, they seemed to be organized, arranged in a way that defied the odds. It was like looking at a Jackson Pollock painting, a masterpiece of random splatters, and noticing that all the largest strips of paint were inexplicably aligned in the same direction. It was a whisper of order in a symphony that was supposed to be purely chaotic. At first, many thought it must be an error, a mistake in the instruments, or an unaccounted-for signal from our own galaxy. Let's try to understand this alignment more deeply. The patterns in the cosmic microwave background can be broken down into different sizes, much like the sound of an orchestra can be broken down into the high notes of the flutes and the low, deep notes of the cellos. In cosmology, this is done with a mathematical tool called a spherical harmonic expansion. The smallest patterns, the high notes, are called the high multipoles. The largest, broadest patterns, the deep notes, are the low multipoles, specifically the quadrupole and the octupole. Think of the quadrupole as a pattern that divides the sky into 2 warm lobes and 2 cool lobes, like a clover leaf. The octupole is a more complex pattern, dividing the sky into regions of warm and cool. According to the standard model, the orientation of the quadrupole and the orientation of the octupole should be completely random and, crucially, completely independent of each other. They should be 2 different notes in the cosmic symphony, playing their own tune without any regard for the other. But in the WMAP data, they were not. The quadrupole and the octupole were found to be uncannily aligned with each other. Their axes, the directions of their main features, pointed in almost the exact same direction. The odds of this happening by pure chance were startlingly low. It was as if the cellos and the basses in the cosmic orchestra were, for some unknown reason, perfectly in sync, playing a deep, resonant chord that echoed across the entire sky. The strangeness did not end there. As researchers stared at this improbable alignment, they noticed something else, something even more disturbing. This shared axis, this direction picked out by the largest features in the very early universe, pointed directly at us. More specifically, the axis was found to be bizarrely aligned with the plane of our own solar system, the ecliptic plane, which is the path the Earth and other planets trace as they orbit the Sun. It also aligned with the direction of our solar system's motion through space. This was a profound, almost philosophical shock. The cosmological principle, the bedrock of modern cosmology, insists that we do not occupy a special place in the universe. Our planet, our star, our galaxy, they are supposed to be typical, unremarkable, adrift in a cosmos that has no center and no preferred directions. Yet here was the baby picture of the entire universe, a map of creation itself, with a giant cosmic arrow painted across it. And that arrow was pointing right at our tiny, insignificant corner of the cosmos. It was as if the entire universe was, in some way, oriented around our solar system. The probability of such a coincidence was calculated to be less than 1 in 1,000. It was a statistical anomaly so significant that it cried out for an explanation. And so, it was given its now famous, ominous name, the Axis of Evil. The name Axis of Evil is, of course, intentionally provocative. It was coined by the cosmologist Mageho, not to imply anything sinister, but to capture the profound and uncomfortable challenge this discovery posed to the foundations of his field. It was evil because it threatened to tear down the elegant, simple, and deeply cherished model of the universe that had been built over decades. The scientific community's first reaction was one of skepticism. The most likely explanation was that the signal was not cosmic at all. It had to be a mistake. Perhaps the methods used to subtract the light from our own Milky Way galaxy were flawed, leaving behind a residual pattern that just happened to look like a cosmic alignment. Or maybe there was some unknown issue with the WMAP satellite itself, some subtle bias in its instruments that created this illusion. These were reasonable, rational explanations, and teams of scientists around the world set to work trying to find the error. They reanalyzed the data. They developed new and more sophisticated models of galactic dust and radiation. They looked for any conceivable source of contamination, from the sun's radiation to the subtle gravitational effects of Jupiter. But the signal would not go away. No matter how they cleaned the data, no matter how they tweaked their models, the alignment persisted. It was robust. It seemed to be real. The hope for a simple explanation then rested on the next generation of cosmic observation. A new satellite, launched by the European Space Agency, was on the horizon. It was called Planck, The Planck satellite was a marvel of engineering, far more sensitive and powerful than WMAP. Its mission was to map the cosmic microwave background with such incredible precision that it would settle the matter once and for all. If the axis of evil was merely an artifact, a ghost in the WMAP data, Planck's superior instruments would not see it. The scientific community waited with bated breath. For years, Planck orbited the sun, patiently collecting photons from the dawn of time. Its data was even cleaner, its resolution even sharper. In 2013, the results were released. The world saw the new, breathtakingly detailed map of the early universe, and there, present and undeniable, was the axis of evil. Planck confirmed the alignment of the quadrupole and octopole. It confirmed the alignment with our solar system. The anomaly was not an error. It was not a fluke. It was a real, physical feature of our universe. The evil was not in our instruments. It was in the sky. This confirmation sent a tremor through the world of cosmology. A simple, comfortable explanation was now off the table. The universe really did have a preferred direction, and it was pointing at us. The question was no longer if the axis was real, but why? So, what could possibly explain this? Scientists, by their nature, look for conventional explanations first. Could there be some new, undiscovered physics at play? Perhaps the universe is not perfectly flat, as we believe. Some have proposed that the universe might have a non-trivial topology, meaning it could be shaped like a donut or some other complex form. In such a universe, the light from the CMB could wrap around, creating repeating patterns and illusions of alignment. Imagine being in a hall of mirrors. You would see your own reflection repeated in strange and aligned ways. Perhaps the universe is a cosmic hall of mirrors, and the axis of evil is just a reflection of our own local neighborhood. Other theories suggest that the physics of the very early universe, during the period of cosmic inflation, was more complex than we thought. Maybe there were other fields of energy present at the Big Bang that left their imprint on the cosmos, creating a kind of grain or texture in the fabric of space-time itself. These are fascinating ideas, but they remain highly speculative. They often require fine-tuning our existing models to an uncomfortable degree, adding in new complexity just to explain this one strange observation. And none of them fully explain the most baffling part of the puzzle. Why does this cosmic axis align so perfectly with our own tiny, seemingly insignificant solar system? This alignment with the solar system is the heart of the mystery. It is what elevates the axis of evil from a mere cosmological curiosity to something that feels profoundly unsettling. It resurrects, in a modern scientific form, an ancient idea that humanity has long since abandoned. The idea of a geocentric or anthropocentric universe. For millennia, we believed we were at the center of everything. The Copernican revolution taught us otherwise. We learned that the Earth orbits the Sun. The Sun orbits the center of the Milky Way. And our galaxy is just one of billions, hurtling through an indifferent cosmos. This is the principle of mediocrity, the idea that we are not special. It is a cornerstone of the modern scientific worldview. And yet, the axis of evil stares back at us, a piece of cosmic evidence that seems to whisper the exact opposite. It suggests a connection, a correlation. between the largest structures in the entire observable universe and the specific orientation of our little planetary system. How could this be? How could the plane in which Earth orbits the sun have any relationship to a pattern that was set in stone 13.8 billion years ago, long before the sun or the Earth even existed? It is a causal nightmare. There is no known physical mechanism that could connect these two vastly different scales of time and space. The improbability of this alignment cannot be overstated. Let's try to frame it with an analogy. Imagine you find an ancient, untouched beach. The sand has been shaped by wind and waves for thousands of years. The patterns in the sand are random and natural. Now you take a single, ordinary grain of sand and drop it anywhere on that vast beach. You then discover that the largest patterns in the sand, the great sweeping dunes and ripples that stretch for miles, are all perfectly aligned with the direction your single grain of sand happened to fall. You would be utterly bewildered. You would know intuitively that this could not be a coincidence. You would suspect that either the grain of sand's fall was not random, or the patterns on the beach were not natural. This is the dilemma presented by the axis of evil. Our solar system is that single grain of sand. The cosmic microwave background is that ancient beach. The alignment between them suggests that something is profoundly wrong with our assumptions. Either our solar system's orientation is not random, which seems impossible, or the universe itself is not what we think it is. The sheer unlikeliness of it all forces us to consider explanations that lie outside the realm of conventional physics. Ideas that were once confined to the pages of science fiction or the dialogues of philosophy. And this is where our journey takes a turn into the truly extraordinary. When faced with an observation that defies all conventional explanation, it is sometimes necessary to question our most fundamental assumptions. What is the most fundamental assumption we make? It is the assumption that the universe is real, that it is a base reality governed by natural laws that emerge from a random, unguided process. But what if that assumption is wrong? Let us now gently open the door to a different possibility, an idea known as the simulation hypothesis. This hypothesis proposes that our reality, everything we see, everything we experience, the stars, the galaxies, our own consciousness is not a physical base reality. Instead, it is an incredibly advanced, high-fidelity computer simulation. We are, in this view, living inside a constructed world, a digital creation. Our universe is a program running on some vast, unimaginable computer in a higher level of reality. This is not a new idea. Philosophers like Plato, with his allegory of the cave, have long mused that our perceived reality might be a mere shadow of a truer one. But in the 21st century, with the rise of computing and virtual reality, this ancient philosophical musing has become a serious, testable scientific hypothesis. The modern argument for the simulation hypothesis, most famously articulated by the philosopher Nika Bostroma, is based on probability. It goes something like this. First, assume that consciousness can be simulated. That is, it is possible to create a self-aware being within a computer program. Given our rapid advances in artificial intelligence, this seems plausible. Second, assume that advanced civilizations, if they exist, would likely run vast numbers of such simulations. They might do it for research, to study their own history, or perhaps simply for entertainment, much like we create video games. Third, if a civilization can run one such simulation, it can likely run billions. A single base reality could therefore give rise to countless simulated realities. If this is the case, then the number of simulated consciousnesses in existence would vastly outnumber the number of real consciousnesses in the base reality. Therefore, based on pure statistics, it is overwhelmingly more probable that we are one of the simulated minds rather than one of the real ones. It is a simple, logical argument that is difficult to refute. It suggests that we should not be surprised to find ourselves living in a simulation. In fact, we should almost expect it. The default assumption should perhaps be that we are not in base reality. If we allow ourselves to entertain this possibility, even for a moment, how would it change our perspective? The world around us would no longer be a product of blind chance, but of intelligent design. The laws of physics would not be fundamental truths, but rather the program rules of the simulation, the code that governs our reality. The Big Bang would not be the ultimate beginning, but simply the moment the simulation was switched on. It is a breathtaking, paradigm-shifting idea. It does not necessarily mean our lives are meaningless. The experiences, the love, the joy, the suffering are all real to us, the inhabitants of the simulation. But it would mean that our universe has a creator or creators, an architect, a programmer. And like any piece of complex software, it might contain artifacts, limitations, or even glitches. A simulated universe might not be perfect. The immense computational resources required to simulate an entire cosmos might lead to shortcuts, optimizations, or rounding errors. And these imperfections, these digital fingerprints of the simulation structure, might be detectable from within. We might be able to find the seams in the matrix. Let us now bring these two streams of thought together. On one hand, we have a profound cosmic anomaly, the axis of evil, which defies all conventional explanation and points to a preferred direction in space centered on our solar system. On the other hand, we have a logical, probabilistic argument that suggests we may be living in a computer simulation. Could the two be connected? Could the axis of evil be the first empirical evidence that we are, in fact, living inside a program? This is the tantalizing proposition put forth by a growing number of physicists and philosophers. They suggest that the axis of evil is not a natural phenomenon at all. Instead, it is a glitch, an artifact, a fingerprint of the simulation's underlying architecture. It is a flaw in the code of our reality, a subtle error that reveals the artificial nature of our world. Let's explore what kind of artifact it might be. There are several fascinating possibilities, each one more mind-bending than the last, each one a potential glimpse behind the curtain of our perceived existence. One possibility is that the axis of evil represents a boundary effect. Imagine a video game world. Even in the most sophisticated open-world games, there is always a boundary, an edge to the map. When you approach this boundary, strange things can happen. The graphics might distort, the physics might behave weirdly, the simulation is no longer perfect at its edges. Now imagine our universe is simulated inside a finite computational space, perhaps a giant sphere or cube in the computer of our creators. If our observable universe is getting close to the edge of this simulated box, we might start to see strange boundary effects. The light from the cosmic microwave background, which has traveled for 13.8 billion years, has traveled the furthest. It is the light that has come from the very edges of our observable sphere. It is therefore the most likely place to see these distortions. The axis of evil, with its strange large-scale alignments, could be the first sign that our reality is not infinite, but is contained within a larger, finite structure. It could be the distortion we see as we gaze towards the edge of the map. The alignment with our solar system might simply be because the simulation is, for computational efficiency, centered on the area of interest, which is us, or at least our part of the galaxy. Another related idea is that the universe is simulated on a grid, a kind of cosmic lattice or pixelation. In any digital simulation, from a simple image to a complex virtual reality, the underlying structure is a grid of discrete points, or pixels. At a large enough scale, this grid is invisible, and the world appears smooth and continuous. But if you could zoom in far enough, you would see the pixels. Some physicists propose that space-time itself might be discrete, not continuous. If our universe is a simulation, it might be running on a vast, three-dimensional grid. The laws of physics, like the movement of particles, would be calculations happening on this grid. And a grid, by its very nature, has preferred directions. The horizontal, vertical, and diagonal axes. It is not perfectly isotropic. The physics of the simulation might be slightly different depending on the direction of travel along this grid. Perhaps the axis of evil is a manifestation of this underlying grid structure. The expansion of the very early universe, the propagation of that first light, might have been subtly influenced by the grain of the cosmic lattice, resulting in the large-scale alignments we see today. The universe is not a perfectly smooth sphere, but a very, very high-resolution crystal, and the axis of evil is revealing the orientation of its crystalline structure. A third, and perhaps more poetic possibility, is that the axis of evil is not a glitch at all, but a deliberate feature, a signature, an artist's mark left on their creation. If you were to create a universe, a simulated reality of immense complexity, might you not be tempted to leave a small, subtle sign of your handiwork? Something that was not obvious at first, but could be discovered by the intelligent beings who evolved within your creation once they reached a certain level of technological sophistication. A kind of cosmic Easter egg. The axis of evil, with its profound statistical unlikelihood and its baffling alignment with our own solar system, is a perfect candidate for such a signature. It is a feature that violates the universe's own apparent rules, a miracle embedded in the very fabric of creation. It says, "This was made. This was designed." It breaks the illusion of a random, naturalistic cosmos and points directly to an intelligence, an architect. In this view, our discovery of the axis of evil is not an accident. It is a milestone, It is the moment the simulated beings look closely enough at the canvas to see the painter's brushstroke. Let's pause and consider the implications of this. If the axis of evil is evidence of a simulation, it changes everything. It re-enchants the universe. The cosmos is no longer a cold, indifferent void, but a place of profound and hidden meaning. Our existence is not a cosmic accident, but the result of a deliberate act of creation. This does not necessarily answer the question of why. Why was this simulation created? Are we a science experiment, a historical reconstruction, a piece of art, an ancestor simulation run by our far future descendants? We cannot know the motivations of the simulators, but the possibility itself fills the universe with a sense of awe and wonder that is almost spiritual. It suggests that the quest of science, the drive to understand the fundamental laws of nature, is not just about uncovering the mechanics of a random universe. It is, perhaps, a process of reverse engineering the code of our own reality. Every new discovery, every law of physics we uncover, is another line of the source code that we are piecing together. We are inhabitants of a program, slowly and patiently learning the language in which we are written. This idea also reframes our place in the cosmos. The Copernican principle of mediocrity, which has humbled humanity for centuries, might be an illusion. The axis of evil's alignment with our solar system suggests that we might, in some way, be special after all. Perhaps we are not at the physical center of the universe, but we could be at the computational center. The simulation might be focused on Earth or on humanity. The rest of the vast, seemingly empty universe could be a backdrop, a computationally efficient rendering of a distant sky, generated for our benefit. Think of the distant mountains in a video game. They are not rendered with the same level of detail as the world immediately around the player. Perhaps the distant galaxies are like that. This doesn't mean they aren't real within the simulation, but it might explain why the universe seems so finely tuned for our existence, and why it appears to be oriented around us. It is not because we are cosmically important in a physical sense, but because we are the subject of the simulation. We are the player character in this grand cosmic game. The universe is our user interface. Of course, this is all speculation. It is a hypothesis born from a single, deeply strange anomaly. The majority of cosmologists are still working to find a more conventional explanation for the axis of evil. They are searching for subtle errors in the data, for new physical theories that could explain it without resorting to such extraordinary claims. And that is the correct and proper process of science. Extraordinary claims require extraordinary evidence. The axis of evil is, for now, just one piece of evidence, but it is a powerful piece. It is a crack in the beautiful facade of the standard model, and through that crack we get a glimpse of possibilities that are both thrilling and terrifying. It forces us to confront the limits of our knowledge, to question the very nature of the reality we inhabit. It reminds us that the universe is under no obligation to make sense to us, or to conform to our expectations of what is natural or simple. The universe is what it is, and our job is to observe it with an open mind, no matter how strange the things we find may be. Let's think about what other evidence we might look for. If we live in a simulation, there might be other glitches, other artifacts waiting to be discovered. Some scientists have suggested looking for a fundamental resolution of space, a smallest possible distance, which would be the pixel size of our reality. The Planck length is a candidate for this. Others suggest that the constants of nature, like the speed of light or the charge of an electron, might not be perfectly constant. In a computer simulation, these values could be subject to tiny rounding errors over vast distances or times. Detecting such a variation would be a smoking gun for a simulated reality. We could also look for signs of computational optimization. For example, some have noted that the rules of quantum mechanics, with their probabilistic nature and the way reality seems to settle into a definite state only when observed, are strangely reminiscent of how a video game might render details only when a player is looking at them. It's a way to save processing power. Perhaps the universe operates on a need-to-know basis, only calculating the fine details of reality when a conscious observer, one of the players, forces it to. The famous double-slit experiment becomes, in this light, not a paradox, but a feature of the rendering engine. The axis of evil remains the most compelling piece of potential evidence we have so far. It is a macroscopic anomaly written across the entire sky. It is not hidden in the esoteric mathematics of quantum mechanics, but is present in the first and grandest picture of our universe. It is a persistent, nagging problem that has resisted all attempts at a conventional solution for 2 decades. It has survived scrutiny from 2 of the most advanced scientific instruments ever built. It is a cosmic riddle. Is it just an extreme statistical fluke, a 1 in 1,000 coincidence that we happen to be here to observe? The universe is vast, and unlikely things are bound to happen somewhere. Perhaps we are just the lucky or unlucky civilization that finds itself living in the middle of a cosmic anomaly. This is the simplest explanation. It requires no new physics, no simulated realities. It only requires us to accept that we have witnessed something incredibly improbable. For many scientists, this is the most rational conclusion. It is Occam's razor. The simplest explanation is usually the best. But there is a counter-argument to this idea of a statistical fluke. It is called the anthropic principle, or more specifically, the selection effect. Perhaps strange, improbable alignments like the axis of evil are not as rare as we think. It is possible that the universe is teeming with such anomalies, but we only find ourselves in a position to observe the ones that are aligned with us. Consider this. Maybe the very conditions necessary for life to arise are somehow linked to these large-scale cosmic structures. Maybe solar systems can only form and remain stable long enough for intelligent life to evolve in these specific, cosmically aligned regions. If that were true, then it would be no coincidence at all that we find ourselves in such a place. We could not have found ourselves anywhere else. It would be a selection bias. We observe the universe to be oriented around us because the only observers who exist are the ones in the oriented parts of the universe. This is another way to explain the anomaly without resorting to simulations, but it creates its own set of deep philosophical questions about the relationship between life and the cosmos. It suggests a universe that is far more interconnected and less random than we ever imagined. So we are left with a landscape of possibilities, each one reshaping our understanding of the cosmos. The first path is that of chance. The axis of evil is a fluke, a statistical outlier that means nothing. Our universe is random, and we are not special. This is the most conservative and, for many, the most comfortable path. The second path is that of new physics. The anomaly is real, and it is telling us something profound about the shape of the universe or the laws that governed its birth. This path leads to a deeper, more complex, but still naturalistic cosmos. The third path is that of anthropic selection. The anomaly is a prerequisite for our own existence, a sign that life is not an accident but is woven into the very fabric of space-time. And the fourth path, the most radical and perhaps the most fascinating, is the path of simulation. The axis of evil is a glitch in the matrix, a feature of the code, a signature of the programmer. It is the first tangible clue that our reality is an artificial construct. There is currently no way to definitively choose between these paths. All we have is the data, the map of that ancient light, with its beautiful patterns and its one profound, impossible flaw. As we drift towards the end of our journey tonight, let us not see this uncertainty as a source of anxiety, but as a source of wonder. The existence of a mystery like the axis of evil is a gift. It tells us that our exploration of the universe is far from over. There are still fundamental secrets waiting to be uncovered. It pushes the boundaries of our imagination and forces us to ask the biggest questions of all. What is reality? Where did we come from? And what is our place in the cosmos? The axis of evil does not give us the answers, but it sharpens the questions in a powerful and urgent way. It is a cosmic whisper, carried across 13.8 billion years of expanding space, to find us here, now, in our small corner of the Milky Way. A whisper that says, "Look closer. The world is not what it seems." It is an invitation to continue our quest for knowledge, to build better telescopes, to devise more clever theories, and to never stop looking up at the sky with a sense of humility and awe. Imagine the programmers of our universe, if they exist. Perhaps they are watching us right now, watching as we, their creations, discover the anomaly they left behind. Are they amused? Are they impressed by our ingenuity? Do they consider our discovery of the axis of evil to be a milestone in our development, a sign that we are waking up within the simulation? Or perhaps the glitch was unintentional, a bug in the code that they are now scrambling to patch. It is a strange and humbling thought to consider that our most profound scientific discoveries might be monitored by an outside intelligence. But it is also an inspiring one. It suggests that our quest for knowledge is not a lonely one, played out in a meaningless void. It might be part of a larger story, a larger purpose that we can only begin to guess at. Our science becomes a form of communication, a way of signaling to our creators that we are here, we are thinking, and we are ready for the next level of the game. So as you lay here on the edge of sleep, let your mind hold on to this image, the image of the infant universe, a sphere of soft, warm light, a nearly perfect sphere, but with one single, elegant flaw, a brushstroke across the canvas of creation, an axis that aligns the grandest cosmic structures with our own humble home. Do not try to solve the riddle. Simply allow it to be. Allow the mystery to wash over you. See it not as a problem, but as a poem written in the language of microwaves. A poem about the deep and hidden structure of reality. Whether it is the signature of a creator, the echo of a forgotten law of physics, or just a beautiful accident of chance, it is a part of our universe. It is a part of our story. And it is a reminder that even in the vast, cold emptiness of space, there are patterns, connections, and mysteries that tie us to the whole, making our small existence part of something immeasurably grand. Let the concept of the axis of evil be a final, calming thought. It represents the frontier of human knowledge, the line where our understanding meets the great unknown. And resting on that frontier is a peaceful place to be. It is a place free from the certainty and rigidity of solved problems, a place of pure potential and wonder. The questions it raises are far more interesting than any simple answer could be. They expand the mind and soothe the soul, reminding us of the infinite complexity and beauty of existence. The faint, aligned glow of the cosmic microwave background is like a cosmic mantra, a deep, resonant hum that has been traveling towards us since the beginning of time. Let that hum be the soundtrack to your sleep tonight, a sound that carries within it the greatest mystery of them all, the true nature of our world, a mystery that we are privileged to contemplate as we drift off into the quiet, personal universe of our own dreams. Tonight, we have journeyed back to the dawn of time. We have gazed upon the baby picture of our universe, the cosmic microwave background. We expected to find a portrait of beautiful, random simplicity. Instead, we found a flaw, an anomaly, a feature so improbable it was named the axis of evil. We saw how the largest patterns in the fabric of creation are inexplicably aligned with each other, and more mysteriously still, aligned with the plane of our own small solar system. We have weighed the possibilities, a statistical fluke of cosmic proportions, a sign of new, undiscovered physics, an anthropic shadow cast by our own existence, or the most reality-bending possibility of all, the first tangible evidence that our universe is a simulation, and this axis is a glitch in the code, a boundary of the map, or the deliberate signature of a creator. The axis of evil stands as a monumental challenge to our understanding of everything. It is a quiet, persistent signal that suggests the universe may not be what we thought. It whispers of a hidden order, a deeper layer of reality, just waiting to be discovered. Thank you for joining this journey to the edge of knowledge. If this exploration of our potential reality has sparked your curiosity, please consider liking this video and subscribing for more deep dives into the mysteries of the cosmos. And as a final thought to carry you into your dreams, I ask you, if you could ask the programmer of our universe one question about the axis of evil, what would it be? Let your answer drift in the comments below. Now sleep well and dream of worlds within worlds.